I remember the exact moment I realized infinity wasn't just a mathematical concept. I was lying in bed, probably around 15 years old, thinking about the night sky. If the universe is infinite, I thought, then beyond the farthest galaxy we can see, there's more universe. And beyond that, more universe. And beyond that, more universe. Forever. Literally forever. The thought wouldn't leave me alone. I kept trying to imagine what forever meant. I'd think, okay, there's matter and galaxies extending infinitely in all directions. But what's at the end? And then I'd remember there is no end because it's infinite, which meant what? That there are infinitely many galaxies, that space goes on infinitely, that somewhere infinitely far away there's an exact duplicate of Earth, with a duplicate of me lying in bed thinking about infinity. The more I thought about it, the more the concept seemed to break something in my mind. Infinity isn't a number. It's a concept that resists intuition. You can't picture infinity. You can't count to infinity. You can't grasp it the way you grasp 1,000 or even 1 billion. But infinity might be real. Space might actually be infinite. And if it is, the implications are so profound that they reshape everything we think we know about the universe. That's what I want to explore in this video, not just whether space is infinite, that's still an open question in cosmology, but what it would mean if it is. What are the implications? What would an infinite universe look like? How would it change our understanding of everything? Let me start with the basics. When cosmologists talk about infinite space, they're usually referring to one of two things. Either the universe extends infinitely in all directions, or it curves back on itself in a way that makes it effectively infinite, like the surface of a sphere, which has no edge and is finite but unbounded. Current observations suggest the universe is flat, neither positively curved like a sphere nor negatively curved like a saddle shape. A flat universe can be either finite or infinite. If it's infinite, then space literally goes on forever. If it's finite but unbounded, it might wrap around on itself in higher dimensions, like how the surface of a globe is finite but has no edges. But let's focus on the possibility that space is truly infinite. Not finite but unbounded, but actually literally infinite. What would that mean? First, it would mean the observable universe. The 46 billion light-year sphere we can see is just an infinitesimal fraction of the whole thing. Our cosmic horizon represents the limit of what we can observe, but beyond that horizon, there's more universe, infinitely more. Our perspective, our observations, our entire cosmic knowledge would be like looking through a tiny window at a vast landscape we can never fully see. This realization troubled me as a teenager, and it troubles many people when they first grasp it. There's something existentially unsettling about the idea that the universe you can observe and study is just an invisible speck in an infinite whole. But let me build up to the full implications. Let me start with what we actually know. The observable universe has a radius of about 46 billion light years. This is the farthest we can see because light from objects beyond this distance hasn't had time to reach us since the Big Bang. It's not that there's a physical wall at 46 billion light years. It's just that that's our observational limit. Beyond the cosmic horizon, the universe continues. We don't know exactly what's beyond it. It could be more of the same, more galaxies, more stars, more structure. Or it could be fundamentally different in ways we can't observe. The question is, how far does it go? Does it extend infinitely? Or does it stop somewhere? And if it stops, what does that mean? What's outside a finite universe? This question has troubled philosophers and theologians for centuries. In medieval times, theologians debated whether the universe was finite or infinite. Some argued God must have created a finite universe with a boundary. Others argued only an infinite universe could be worthy of an infinite God. Modern cosmology has tried to answer this question through observation. Current evidence from measurements of cosmic microwave background radiation suggests the universe is flat. Its geometry matches Euclidean geometry rather than spherical or hyperbolic geometry. If the universe is flat, it could still be finite. If it curves back on itself in higher dimensions, or infinite, if it truly extends forever. Current observations can't definitively distinguish between these possibilities, but mathematically and theoretically, an infinite universe is entirely possible. General relativity, Einstein's theory of gravity, doesn't require the universe to be finite. An infinite flat universe is consistent with general relativity. So let's explore what an infinite universe would mean. If space is infinite, then there are infinitely many galaxies, infinitely many stars, infinitely many planets. This isn't hyperbole or metaphor. Literally infinite, larger than any number you can think of. With infinite space and planets, what's the probability that life emerges on a given planet? Extremely low, perhaps 1 in a billion or 1 in a trillion. But even an extremely low probability, when multiplied by infinity, produces infinity. This means an infinite universe would have infinitely many habitable worlds, infinitely many biospheres, infinitely many planets with life. Going further, if intelligent life emerges with some probability, then an infinite universe would have infinitely many intelligent civilizations, infinitely many conscious beings thinking about existence, infinitely many observers of the universe. This is profoundly different from a finite universe where life might be rare, even unique. But there's something even more radical that follows from this. If space is infinite, and if the number of possible configurations of matter is finite, which it is, given a finite number of atoms, then every possible arrangement of matter must occur somewhere in the infinite universe. Think about that for a moment. Consider all the atoms in your body. There are about 7 times 10 to the 27th power atoms. The number of ways to arrange these atoms is extraordinarily large but finite. In an infinite universe, this exact arrangement exists infinitely many times. There are infinitely many copies of you, infinitely far away, living infinitely many variations of your life. Some of these copies are identical to you in this moment. Same thoughts, same position, same everything. Most are different in small ways. Some are radically different. Versions of you that made different choices, that lived different lives, that never existed at all in your actual life. In an infinite universe with the implication I just described, every possible version of you is out there somewhere living. Every life you could live is being lived by some version of you. This is sometimes called the infinite multiverse or the many worlds cosmological interpretation. It's not something we can test or verify observationally, but it's a logical consequence of an infinite universe with finite possible configurations. I find this thought simultaneously liberating and disturbing. Liberating because it means every possible version of you succeeds at something, finds love, accomplishes great things. Distributed across infinite copies, you achieve infinite potential. But disturbing because it means your individual choices don't matter. You make a choice, but somewhere another version of you is making the opposite choice. Both outcomes are realized. Your agency becomes illusory. How do you interpret that? Is it meaningful to choose if all choices are made? Or is the meaning in the choosing itself, regardless of whether other versions of you choose differently? I think the answer depends on your philosophical framework. But the point is, an infinite universe has implications that are genuinely hard to think through. Let me explore another implication. If space is infinite, it's probably also eternal. The universe is expanding now, and the expansion is accelerating. This means that billions of years in the future, the universe will be vastly larger than it is now. Galaxies will recede farther and farther apart. Eventually, stars will burn out. Eventually, black holes will evaporate. But this process takes an incomprehensibly long time. The universe will undergo heat death over timescales of maybe 10 to the power of 100 years, A1 followed by 100 zeros. In a finite universe, after heat death, there's just nothing. Cold, empty space filled with elementary particles at maximum entropy. The story ends. But in an infinite universe, there's infinitely much space, infinitely much time ahead. Long after stars have stopped shining and black holes have evaporated, space continues. Particles continue moving through the void for eternity. What does an infinite universe look like after heat death? It's still infinite, infinitely vast, infinitely old, infinitely empty, just space and particles forever. Actually, here's a disturbing thought. In an infinite universe, even after heat death, random quantum fluctuations will occasionally create brief, localized complexity. A region of space might randomly organize itself into atoms, molecules, even structures resembling life or consciousness. In an infinite universe with infinite time, even incredibly unlikely events will eventually occur, infinitely many times. This leads to some philosophical speculation. Could the Big Bang itself be a random quantum fluctuation in a pre-existing infinite void? Could our universe be just one of infinitely many universes spawned from random fluctuations in an infinite spacetime? This gets into territory where science becomes speculation. We can't test these ideas, but they follow logically from the premise of an infinite universe. Let me shift gears and talk about what an infinite universe means for the distribution of matter and structure. In a finite universe, you can talk about the total amount of matter, the average density, the total number of galaxies. These are well-defined quantities. In an infinite universe, there are infinite galaxies, infinite stars, infinite planets. The total amount of matter is infinite. The total energy is infinite, but the density, the amount of matter per unit volume, can still be finite and measurable. We observe that space has an average density corresponding to about 5% ordinary matter, 27% dark matter, and 68% dark energy. This average density is the same everywhere as far as we can measure. If the universe is infinite, it maintains this average density infinitely far away. There are infinitely many regions of space, each with the same average density, stretching to infinity. This has implications for structure. On large scales, the universe has cosmic structure, filaments of galaxies separated by voids. If the universe is infinite, this structure continues infinitely. Infinitely many filaments, infinitely many voids, extending forever. On smaller scales, the structure repeats. The patterns that we see in the nearby universe, galaxy clusters, galaxy superclusters, cosmic web architecture, repeat infinitely throughout space. This idea is sometimes called cosmic homogeneity. On large enough scales, the universe looks the same everywhere. An observer in a galaxy billions of light years away would see essentially the same cosmic structure around them as we see around us. In an infinite universe, homogeneity means the universe looks the same everywhere because it actually is the same everywhere. The same average density, the same types of structures, the same physical laws operating identically. This is comforting in some ways. It means we're not special, but neither is any other location. We're in a completely typical region of space in an infinite, homogeneous universe. Let me talk about what this means for cosmology and our understanding of physical laws. One of the principles that guides modern cosmology is the Copernican principle, the idea that we don't occupy a special place in the universe. We're in an ordinary galaxy, around an ordinary star, in an ordinary region of space. An infinite universe reinforces the Copernican principle to an extreme degree. We're not just in an ordinary location, we're one of infinitely many ordinary locations, all identical to ours. But this raises a question. If the universe is infinite and homogeneous, how did we determine the laws of physics by studying just one infinitesimal region? The answer is that the laws of physics seem to be universal. Gravity works the same way billions of light years away as it does here. Chemistry works the same way. The speed of light is the same everywhere we measure it. Time flows at the same rate everywhere, adjusting for gravitational and relativistic effects. This universality of physical law is not guaranteed. It's possible in principle that physics could be different in distant regions, but observations suggest the laws are the same everywhere. An infinite universe with universal physical laws means the universe is fundamentally predictable and comprehensible. The laws we derive here apply everywhere. We can understand the distant universe using the same physics that governs local phenomena. This is remarkable. The universe is so large that we can only observe an infinitesimal fraction, but that fraction is enough to determine the fundamental laws governing the entire infinite cosmos. Now let me explore a question that's bothered philosophers. If space is infinite, does that contradict the idea that the universe had a beginning? The Big Bang is often described as the beginning of space and time. Before the Big Bang, there was no space, no time, no universe. The Big Bang created space and time, but in an infinite universe, how can space have had a beginning? Doesn't infinite space require infinite time to create? The resolution is that infinite space and finite time since the Big Bang aren't contradictory. The Big Bang created space, and that space was immediately infinite. Or more precisely, the Big Bang created space-time as a four-dimensional entity, with space being infinite and time having a beginning. This is hard to visualize, but it's consistent with general relativity. The universe can be spatially infinite but temporally finite, infinite at this moment but finite in duration since its beginning. Alternatively, the Big Bang might not have created space itself, but rather initiated the expansion of space that was already there. Or there might be a pre-Big Bang state that we can't observe or understand. These are deep questions that physicists are still grappling with. But the point is, an infinite space and a Big Bang are not necessarily contradictory. Let me address a question that often comes up. If the universe is infinite, where is the center? Where is the edge? An infinite universe with no boundaries has no center and no edge. Every point in space is equally central. There's infinitely much space in all directions around every point. From any observer's perspective, they're at the center of infinity. This sounds paradoxical, but it's a consequence of infinity. Infinity has no center, no edge, no privileged location. This relates to the geometry of space. In a flat, infinite universe, Euclidean geometry applies. Parallel lines remain parallel. The angles in a triangle add up to 180 degrees. Space extends infinitely in all directions. In a spherical universe, space curves back on itself. There's no center in 3D space, just as the surface of a sphere has no center on the surface itself. There's no edge. You can travel around the sphere and never fall off. In a hyperbolic universe, space is negatively curved, like a saddle. It's also unbounded and has no center. Current observations suggest our universe is flat, consistent with Euclidean geometry. A flat universe can be finite if it wraps around in higher dimensions, or infinite. If it's infinite and flat, then space truly goes on forever, with no center and no edge. Every location is equally central and equally peripheral. You're standing at the center of an infinite cosmos, and so is every other observer, infinitely far away. Now let me explore what an infinite universe means for the future of humanity and intelligent civilizations. If we assume life and consciousness emerge according to some probability, then an infinite universe with infinitely many worlds means there are infinitely many civilizations. Some might be older than us by trillions of years. Some might be younger. An old civilization, given enough time, might develop technology we can't imagine. They might figure out how to manipulate space-time. They might build structures on cosmic scales. They might even figure out how to travel or communicate across vast distances. But here's a disturbing thought. In an infinite universe, even a civilization that spreads at the speed of light, the fastest possible speed, can only ever reach a finite volume of space. They can influence an infinite space of radius equal to the distance light travels in the time they've existed, but the universe as a whole remains infinite. This means no civilization, no matter how advanced or how long-lived, can ever explore or colonize the entire universe. An infinite universe is essentially beyond the reach of any finite civilization, no matter how large or long-lived. This has implications for the Fermi Paradox, the question of where all the alien civilizations are. If the universe is infinite and civilizations eventually go extinct or cease expanding, then the galaxies beyond our cosmic horizon might be full of life that we'll never encounter. We might be isolated not because life is rare, but because space is so vast that civilizations can't meaningfully interact across cosmic distances. Alternatively, if civilizations are rare enough, then even an infinite universe might be sparsely populated. Infinitely many stars, but finitely many civilizations spread infinitely thin. Let me explore the philosophical implications of an infinite universe more deeply. There's something about infinity that challenges human meaning-making. We evolved to think in terms of finite resources, finite time, finite possibilities. We have maybe 80 years to live. We have limited energy. We can explore only a small part of the world. Infinity breaks these frameworks. An infinite universe means infinite possibilities, infinite time, in spatial terms, infinite resources distributed across infinite space. Some people find this liberating. An infinite universe means anything is possible. Somewhere in some region of infinite space, every conceivable scenario plays out. Others find it depressing. An infinite universe means your individual existence is infinitesimally insignificant. Your life, your choices, your achievements, they're all happening against a backdrop so vast that they're essentially invisible. I think both reactions are understandable, but I also think there's a third perspective. An infinite universe is remarkable precisely because it exists at all. The fact that space is infinite, or even if it's finite but vast, is extraordinary. And the fact that consciousness emerges within this infinity, that observers exist and can contemplate their cosmos, that we can ask questions about infinity itself, that's remarkable. Let me talk about how we might determine whether space is actually infinite. The honest answer is we probably can't, at least not with current or foreseeable technology. The observable universe is defined by the cosmic horizon, the farthest distance light has traveled since the Big Bang. We can't see beyond this horizon. We can't send messages beyond it. We can't explore it. Beyond the cosmic horizon, there's almost certainly more universe, but we can't observe it directly. However, there are indirect ways to constrain whether the universe is finite or infinite. One approach is to look at the geometry of space. If space is positively curved, like a sphere, then the universe is finite. We can measure the curvature of space using observations of the cosmic microwave background radiation. Current measurements suggest space is flat, neither positively nor negatively curved. A flat universe can be finite or infinite, so this doesn't definitively answer the question. Another approach is to look for patterns in the cosmic microwave background that would indicate the universe wraps around on itself. If the universe is finite but unbounded, with a spherical or toroidal topology, then the cosmic microwave background might show patterns corresponding to this topology. Searches for such patterns have not found evidence of a closed universe topology. This is consistent with either an infinite universe or a finite universe with a very large radius, so large that we can observe the wraparound. Another consideration, in a finite, compact universe, you might eventually see the back of your own head if you looked far enough away. Light from your galaxy could travel around the universe and return to you, giving you a glimpse of yourself as you were billions of years ago. Observations don't show evidence of this either. So current evidence is consistent with an infinite universe, but it doesn't prove it. The universe might be finite, but so large that we can't detect its finiteness. Philosophically, there's an argument sometimes made. If the universe is finite, what's outside it? What's beyond the boundary? This question bothered people for centuries. The modern answer is that outside might not be a meaningful concept. If the universe is finite but unbounded, curved back on itself in higher dimensions, then there is no outside. Just as the surface of a sphere has no outside. There's 3D space beyond it, but the surface itself doesn't extend to an outside. Similarly, space-time itself might be fundamentally finite. There might be no outside space-time because space-time is all there is. But if space is truly infinite, then there's no boundary to encounter. Infinitely much space in all directions. No edge, no center, no outside. I find the concept of true infinity unsettling. I prefer the idea of a very large but finite universe. At least then there's a boundary, something definite. Infinity is harder to wrap my mind around, but intellectually, I recognize that infinity is possible, perhaps even likely. Let me explore one more implication: what an infinite universe means for the question of God. For centuries, theologians debated whether God required a finite or infinite universe. Some argued an infinite universe could be the only creation worthy of an infinite being. Others argued God must have created something with definite finite bounds. Modern cosmology doesn't address the theological question directly, but it does tell us that if the universe is infinite, it's infinitely old in spatial terms, if not temporal terms. It contains infinitely many worlds, infinitely many observers, infinitely many possibilities. Some theologians find this exciting, the idea of an infinitely vast creation reflecting divine infinity. Others find it threatening. An infinite universe seems to leave no room for God. Personally, I think an infinite universe, far from contradicting the concept of a creator, might actually reinforce it. How could anything other than an infinite being conceive of and create an infinite universe? But these are philosophical and theological questions, not scientific ones. What science can tell us is this: the universe is vastly larger than we can observe. It might be infinite. If it is, the implications are staggering. Infinitely many worlds, infinitely many observers, infinite complexity and possibility. Let me return to that 15-year-old me, lying in bed, thinking about infinity. What would I tell him now? I'd say, the universe might be infinite, probably is based on current evidence. And yes, that means there are infinitely many copies of you, infinitely far away, living infinitely many variations of your life. It's a lot to think about. It might make you feel insignificant, but don't let it. The fact that you exist, that you can think about infinity, that you're part of an infinite cosmos that's become aware of itself through you, that's remarkable. You're one observer in an infinitely vast universe. Your observations, your thoughts, your consciousness, they're all happening against a backdrop so large that it exceeds comprehension. But they're happening. You're here now thinking these thoughts. That's enough. That's more than enough. That's extraordinary. I think the real wonder of an infinite universe is not that we're insignificant, though we are, but that significance is possible at all. That consciousness, thought meaning, can emerge in an infinite void. That's what I contemplate now when I think about infinity. Not my insignificance, but the miracle that anything significant, me, you, consciousness, meaning, can exist at all. An infinite universe is overwhelming. It's hard to think about. It challenges our intuitions and our sense of self. But it's also beautiful. It's vast and complex and full of possibilities we can barely imagine. If space is infinite, and it might be, then we live in a cosmos that's truly beyond comprehension. Not because we're stupid or limited, but because infinity is fundamentally beyond finite minds. And yet we can contemplate it. We can build models. We can develop intuition. We can understand, at least in part, what an infinite universe would mean. That's the human achievement, to reach beyond our limitations, to think about concepts that defy intuition, to contemplate infinities. That's what I want to leave you with. If space is infinite, we're not insignificant. We're remarkable precisely because we exist in infinity and can comprehend it. Thanks for watching. The concept of infinity has troubled mathematicians and philosophers for thousands of years. The ancient Greeks didn't really accept infinity as a valid concept. Aristotle distinguished between actual infinity, something infinite in complete form, and potential infinity, something that could be infinitely large if you kept adding to it. Most ancient thinkers rejected actual infinity. For medieval theologians, only God could be truly infinite. The universe being created was finite by definition. To suggest the universe was infinite seemed to challenge God's uniqueness as the only truly infinite being. Galileo observed something interesting about infinity. He noted that there are infinitely many integers, 1, 2, 3, and infinitely many perfect squares, 1, 4, 9, 16. Yet there are fewer perfect squares than integers, because not every integer is a perfect square. How could one infinity be smaller than another infinity? This paradox troubled mathematicians until Georg Cantor developed set theory in the late 19th century. Cantor showed that infinities come in different sizes. The set of integers is countably infinite. You can in principle list them all, even though the listing would take forever. The set of real numbers is uncountably infinite, larger than the set of integers. There's no way to list all real numbers because there are more of them than integers. Cantor proved you can always construct a larger infinity. For any infinite set, you can create the power set and the set of all subsets, which is strictly larger. This means there's no largest infinity. There are infinitely many sizes of infinity. This mathematical framework helps us think about an infinite universe. If space is infinite, it contains infinitely many locations. The number of possible configurations of matter at those locations is at most countably infinite, assuming a discrete universe, or uncountably infinite in a continuous universe. But the implications remain. Infinitely many configurations repeated infinitely many times across infinite space. Some philosophers find meaning in these infinities. If God is infinite and creates an infinite universe, there's a kind of symmetry. Others find it troubling that the universe seems to have a mathematical structure independent of God. What's remarkable is that these ancient philosophical problems are still relevant to modern cosmology. We're still asking, is the universe infinite? What would that mean? How does our mind even grasp such a concept? Let me explore some thought experiments that illustrate what an infinite universe means. Imagine you have a library that contains every possible book, every combination of letters and words that could form a book. The Library of Babel, as Jorge Luis Borges called it in his famous story, would be infinite. It would contain every book ever written, every book that will ever be written, and every book that could possibly be written, but never will be. Most books in this library would be gibberish, random combinations of letters. But somewhere in this infinite library, there's a book that's an exact duplicate of this video script. And another copy, and infinitely many more. An infinite universe is like this. With infinite space and a finite, though unimaginably large, number of possible configurations of matter, every possible configuration occurs infinitely many times. Here's another thought experiment. Imagine the universe is a computer simulation running on an infinite computer. The simulation has rules, physics, initial conditions, the Big Bang, and deterministic evolution, particles following physical laws. In this infinite simulation, every possible outcome of every possible scenario would eventually occur. You could trace through the simulation and ask, at what locations and times would atoms arrange themselves to form a human? An infinite simulation would contain infinitely many such arrangements. But here's the unsettling part. There's no reason to believe your particular conscious experience is special. Your consciousness right now, reading this, is just one instance of a possible conscious experience. There are infinitely many instances happening at other times and places. This is sometimes called the Boltzmann brain problem. A Boltzmann brain is a consciousness that spontaneously forms from random molecular motion out of a thermal equilibrium state. In an infinite universe with infinite time, random fluctuations would eventually create brains with any particular conscious experience you can imagine. This creates a puzzle. Why do we experience the particular history and current moment we do, rather than some other moment? If every possible moment is equally likely, why is my subjective experience this one? Some philosophers argue this suggests the universe is not infinite because the Boltzmann brain paradox becomes intractable in an infinite universe. Others argue it just means we need to be more careful about how we assign probabilities in infinite spaces. This is deep philosophical territory, but it illustrates how infinity creates genuine puzzles about the nature of conscious experience. When mathematicians talk about different types of universe topologies, they're describing the large-scale shape of space. A positively curved universe is like the surface of a sphere. It's finite but unbounded. You can travel as far as you want and never fall off an edge, but the total volume is finite. A positively curved universe wraps back on itself. A negatively curved universe is like the surface of a saddle. It's also unbounded but infinite in volume. In a hyperbolic universe, parallel lines diverge from each other. Triangles have angles that sum to less than 180 degrees. A flat universe has zero curvature. It's Euclidean geometry. Parallel lines remain parallel. Triangle angles sum to 180 degrees. Our observations suggest our universe is flat, but there's an important caveat. The curvature might be so slight that we can't measure it. The universe could be very weakly positively curved, appearing flat on the scales we can observe. This is important because a very large but finite positively curved universe would appear flat locally. From our perspective within it, space looks flat. But on truly cosmic scales, beyond our observational horizon, the universe would curve back on itself. So there's a range of possibilities between an infinite universe and a finite but enormous universe. We can't definitively distinguish between them with current technology. But here's a key point. If the universe is positively curved and finite, but very large, then from our perspective, it might as well be infinite. We could never reach the boundary, never observe the curvature, never detect the wraparound. So in a practical sense, there are only two possibilities. One, the universe is genuinely infinite, or two, the universe is so large that it's effectively infinite from any observer's perspective. Either way, the implications are similar. An effectively infinite universe behaves like an infinite universe from our perspective. But there are some theoretical differences. A truly infinite universe has infinite volume, infinite matter, infinite time, in a spatial sense. A finite but enormous universe has finite volume and finite matter, but the volume is so large that anything that could happen in an infinite universe within its observable region could also happen in a sufficiently large, finite universe. This distinction matters for some theoretical calculations, but for most practical purposes, a sufficiently large, finite universe is indistinguishable from an infinite one. One of the most profound implications of an infinite universe is how it transforms our understanding of probability and rarity. In a finite universe, rarity means something definite. If only 1 in a billion planets develops life, and there are 10 to the 24th power planets total, then there are 10 to the 15th power biospheres. Life is rare, but the total number is definite and measurable. In an infinite universe, if the same probability applies everywhere, then there are infinitely many biospheres, infinite life, infinite consciousness. This changes the question from, is life common or rare, to how rare must life be for it to remain finite despite infinite space? For life to remain finite in an infinite universe, its probability would have to decrease with distance in a specific way. But there's no reason to believe physics changes with distance in the way that would be required. So the most straightforward interpretation is that an infinite universe with even a tiny probability of life contains infinite life. But here's where it gets philosophically interesting. What does it mean to say something is rare? if it's infinite. Consider, if there are infinitely many Earths and infinitely many copies of you, is Earth still a rare type of planet? Are you still a unique consciousness? By some measures, no. You're one of infinitely many. You're not special. There are infinitely many versions of you that are identical to you, and infinitely many that differ from you in every possible way. But by other measures, Earth is still remarkable. It's a planet where life emerged, where consciousness developed. Among infinite planets, perhaps only infinitely many have life. That's still a tiny fraction. Infinity divided by infinity can be anything. This reveals a fundamental issue with infinity. Intuitions about probability and proportion break down. In finite sets, we can ask, what fraction of planets have life? And get a meaningful answer. In infinite sets, we can ask the same question, but the answer might be indeterminate or nonsensical. Mathematicians have developed ways to handle this. Techniques like taking limits, using measure theory, defining probability carefully. But these technical solutions don't fully resolve the philosophical puzzle. If I told you that in an infinite universe there are infinitely many Earths and infinitely many copies of you, but also infinitely many Earths with no life, and infinitely many barren regions of space with no structure at all, how would you process that information? You'd be trying to compare infinite quantities, and your intuitions about comparison would fail. You can't really say there are more copies of you than there are empty regions of space when both are infinite. You need technical mathematical definitions to make sense of it. This is one reason an infinite universe is so hard to think about. Our intuitions about proportion and frequency are based on finite sets. Applying them to infinity leads to confusion. There's an interesting connection between quantum mechanics and the concept of an infinite universe. In quantum mechanics, particles don't have definite properties until they're measured. An electron doesn't have a definite position until you measure it. Instead, it exists in a superposition of all possible states, all possible positions, momenta, spin values, etc. When you make a measurement, the superposition collapses to one definite outcome. The question is, what determines which outcome you observe? The many worlds interpretation of quantum mechanics suggests that all possible outcomes actually occur. When you measure an electron's position, the superposition doesn't collapse. Instead, the universe branches into infinitely many versions, one for each possible outcome you could observe. In each branch, you observe one particular outcome. Across all branches, every possible outcome is observed infinitely many times. This interpretation, controversial as it is, provides an interesting framework for thinking about an infinite universe. If quantum mechanics truly produces infinite branching, then perhaps the multiverse of quantum mechanics is connected to the infinite cosmos of cosmology. Some physicists speculate that quantum indeterminacy and cosmic inflation might be related, that quantum fluctuations in the early universe led to eternal inflation, creating infinite universes or infinite regions within one universe. If true, this would mean the universe's infinity is a direct consequence of quantum mechanics. The probabilistic nature of quantum events, played out across infinite spacetime, leads to infinite possibilities being realized. This is highly speculative, but it illustrates how modern physics raises genuine questions about infinity and the multiverse. Another connection: if space is infinite and physics produces infinite branching via quantum indeterminacy, then there's an infinity of infinities. Not just infinitely many copies of you, but infinitely many universe branches where you make different choices, And in each branch, space continues infinitely. This is dizzying to contemplate, but it follows logically from combining quantum mechanics and an infinite universe. The second law of thermodynamics states that entropy in an isolated system always increases. The universe, being isolated, there's nothing outside it, must be increasing in entropy. The universe started in a state of very low entropy, extremely ordered, all matter concentrated in an infinitely dense point. Since the Big Bang, entropy has been increasing. The universe is becoming more disordered. Eventually, the universe will reach maximum entropy, a state where matter is evenly distributed and no energy gradients remain. No complex structures, no life, no processes. This is called heat death. In a finite universe, heat death is the absolute end. Everything winds down. The universe becomes a cold, static expanse of particles at equilibrium. But in an infinite universe, heat death is just a new kind of state. Still infinite, still empty, but now truly static. Here's where it gets interesting. Even in maximum entropy, quantum fluctuations never truly stop. Random fluctuations in the quantum fields can create temporary structures, particles appearing and disappearing, regions of order briefly forming before dissolving back into disorder. In an infinite universe with infinite time, even extraordinarily unlikely events will eventually occur infinitely many times. This means that after heat death, in the unimaginably distant future, timescales like 10 to the power of 10 to the power of 100 years or longer, quantum fluctuations might spontaneously recreate ordered structures. Atoms might randomly assemble into molecules. Molecules might form complex structures. In a truly infinite universe with infinite future time, you might expect literally anything that's not forbidden by physical law to eventually occur. This creates a strange picture. The universe dies, but then continues existing forever. And in that forever, rare quantum fluctuations occasionally create brief moments of complexity, a pocket of organization lasting microseconds before dissolving back into disorder. Some physicists speculate about an eternal return, that in an infinite universe with infinite time, even the Big Bang might be recreated by quantum fluctuations. The universe might cyclically create ordered states that expand and cool and approach heat death, only to have quantum fluctuations trigger another Big Bang. This is highly speculative and probably unfalsifiable, but it illustrates how an infinite universe raises questions about what's possible given enough time and space. An interesting concept in modern physics is holographic principle, the idea that all information in a volume of space can be encoded on its boundary. This principle suggests that a finite volume of space contains a finite amount of information. The amount of information is proportional to the surface area of the region, not its volume. If true, this has implications for an infinite universe. An infinite universe would contain infinite information distributed across infinite space. But here's a puzzle. If you take a finite subset of an infinite universe, say a sphere of radius 46 billion light years, how much information does it contain? Finitely much, according to the holographic principle. But the infinite universe as a whole contains infinitely much. This raises questions about whether the infinite universe can be fundamentally different from the observable universe. If the observable universe contains finitely much information and the universe is homogeneous, then couldn't you describe the entire infinite universe using the information in your light cone? Some physicists argue yes. that an infinite homogeneous universe doesn't contain fundamentally more information than a large finite universe. The structures repeat infinitely, so you need infinite instances of the same information, but no new information beyond what's in the observable universe. Others argue that infinite information, even if repetitive, is qualitatively different from finite information. Infinity changes the nature of what's possible. This connects to fundamental questions about what information means in physics. Is a repeated pattern more or less information than a unique pattern? If the universe is infinite and consists of infinitely many copies of similar patterns, is that a high amount of information, infinite or low, just the information of one pattern repeated? These are open questions in information theory and physics, but they illustrate how infinity raises profound questions about the structure of reality. Where is everybody? This is the Fermi Paradox, the puzzle of why we haven't detected signs of alien civilizations despite the apparent ubiquity of habitable planets and stars. One possible answer: civilizations are extremely rare. But another possible answer: the universe is so vast that civilizations are separated by distances that make communication and contact virtually impossible. In an infinite universe, even if life emerges relatively commonly, the spacing between civilizations might be so large that no civilization ever encounters another. Think about it. If intelligent civilizations emerge with a certain probability and are distributed randomly throughout infinite space, their average separation would be enormous, perhaps light years, billions of light years, or unimaginably greater distances. Even a civilization that survived for trillions of years and expanded at the speed of light would only occupy a finite volume of space. In an infinite universe, they'd be isolated on an island of civilization surrounded by infinite empty space. Other civilizations might exist, but they'd be so far away that no communication could ever pass between them. The universe would seem empty to each civilization, even if it was teeming with life elsewhere. This is a possible solution to the Fermi paradox. Not that intelligent life is unique or extremely rare, but that space is so vast that each civilization is effectively alone, unable to contact or even detect others. Furthermore, if civilizations self-destruct or cease expanding after some time, they might leave traces that other civilizations could detect. But in an infinite universe, finding those traces would require essentially perfect astronomical observation and an incredible amount of luck. An infinite universe raises the stakes of the Fermi paradox. Instead of asking, "Are we alone?" it asks, "Is anyone ever in contact with anyone else in an infinitely large cosmos?" The answer is probably almost never, and by accident only. How do we actually measure the size of the universe and what constraints that puts on, whether it's infinite? One method is through analyzing the cosmic microwave background radiation. The CMB is the oldest light in the universe, emitted when the universe was about 380,000 years old. By studying tiny temperature fluctuations in the CMB, astronomers can infer properties of space-time. If space is finite but curled up in a way we can't directly observe, there might be patterns in the CMB that reveal this curvature. For example, in a finite universe with a spherical topology, light could travel around the universe and create certain identifiable patterns. Searches for such patterns have not found evidence that space is finite. This is consistent with space being infinite, but it doesn't prove it. Another constraint comes from measuring the large-scale structure of the universe. We can map out where galaxies are, how they're clustered, what patterns they form. If the universe has a finite size, we'd eventually encounter boundaries or wraparound effects. Current measurements show no sign of such boundaries. The universe appears structurally similar in all directions at large scales, consistent with an infinite or very large homogeneous space. Another approach is through precise measurements of the universe's geometry. General relativity predicts that space can be curved, positively, closed, finite, negatively, open, infinite, or flat, can be either finite or infinite. Current measurements from the cosmic microwave background suggest space is very close to flat, but there's uncertainty in these measurements. Space could be slightly positively curved, which would indicate a finite universe. To definitively measure positive curvature and prove the universe is finite would require extraordinarily precise observations. We're not there yet, so where does this leave us? Current observations are consistent with an infinite universe, but they don't prove it. The universe could be finite, but so large that we can't detect its finiteness. This uncertainty is actually profound. We live in an age where we can measure cosmic distances and determine the universe's age. We can, in principle, test whether space is finite or infinite, and yet the test remains just beyond our reach. Here's a philosophical question that infinity raises. If there are infinitely many copies of you, infinitely far away, making all possible choices and living all possible lives, what does it mean to be you? Consider, right now, you're making a choice. Maybe it's something small, like which word to read next. Maybe it's something large, like a life decision. In a finite universe, your choice matters because it determines what happens. Your life unfolds in a particular way based on your choices. But in an infinite universe where all possibilities are realized, your particular choice seems to matter less. Somewhere, a version of you is making the opposite choice. Both outcomes occur. What makes one outcome yours? This raises questions about free will and personal identity. Do you have free will if all choices are made somewhere? Are you a unique individual if infinitely many copies of you exist? Some philosophers argue that personal identity depends on psychological continuity, your memories, your personality, your beliefs. If there are infinitely many versions of you with slightly different memories or personalities, then personal identity becomes fuzzy. You can't definitively say, I'm the one in location X because infinitely many yous exist. Your subjective sense of being a particular individual becomes problematic. Others argue that personal identity is relative to your timeline. You're the version of you that traces back to your actual past. Even if infinitely many copies exist, you're the one with your particular history. But here's the unsettling part. In an infinite universe, there's no reason your timeline is more real or fundamental than any other timeline. Your particular sequence of experiences is just one of infinitely many. This creates a kind of existential vertigo. You feel like you're a unique individual making unique choices, but an infinite universe suggests you're one instance of a pattern repeated infinitely. How do you live with that? How do you find meaning in your choices if all choices are made? I think the answer is that meaning is personal and subjective. Your experience of choice, your feeling of agency, your subjective sense of being you. These are real from your perspective, even if the universe's perspective is indifferent. You're the consciousness experiencing this moment. That's real. That matters. That's enough, even in an infinite cosmos. One of the most profound observations in modern cosmology is that the universe appears fine-tuned for life. Small changes to fundamental constants, like the strength of gravity or the charge of the electron, would result in a universe where stars, planets, and life as we know it couldn't exist. This is called the fine-tuning problem. Why are the constants of nature such that complex structures can form? One possible answer: there are infinitely many universes with different constants, and we necessarily find ourselves in one where the constants permit our existence. This is the anthropic principle applied to the multiverse. If space is infinite and different regions have different physical constants, perhaps due to cosmic inflation or quantum effects, then there would be regions where gravity is too strong and regions where it's too weak, regions where atoms can't form and regions where they form easily. We, being made of atoms and dependent on chemistry and gravity, necessarily find ourselves in one of the rare regions where physics permits complex life. An infinite universe would contain all possible combinations of physical constants. Some regions would have physics completely unlike ours. Some would be similar. In the infinite cosmos, every possible universe exists somewhere. This is a profound philosophical implication. It means there's no mystery to why our universe is fine-tuned. It's not that it's improbably lucky. It's that there are infinite universes, and we necessarily observe the one where conditions permit our existence. Of course, this doesn't prove an infinite universe exists. It's a possible explanation for fine-tuning, but there are others. But the point is, an infinite universe provides a framework for understanding apparent improbabilities. Infinities make even extremely unlikely events inevitable. This reframes questions about cosmic luck. Instead of asking, how improbably unlikely is our universe, we ask, given infinite possibilities, how likely is it that observers find themselves in regions compatible with their existence? The answer is very likely. Guaranteed, in fact. Observers can only observe regions compatible with their existence. There's an important distinction between a universe that's infinite in space and a universe that's infinite in time. Our universe had a beginning, the Big Bang, approximately 13.8 billion years ago, but it had no spatial boundary at the Big Bang moment. Space was created at the Big Bang, and it was created in an infinite or very large configuration. This might seem paradoxical. How can something infinite be created in a finite time? The resolution is that infinite and created operate on different dimensions. Time is one dimension. Space is 3 dimensions, or more if we count higher dimensions. The universe can have finite age while having infinite spatial extent. Think of it like this. Imagine a movie where the spatial scene is infinite, but the movie has a beginning. The first frame shows an infinite landscape. Time starts at frame 1, but space is already infinite. Similarly, at the moment of the Big Bang, space sprang into being in an infinite or very large configuration. Time began at that moment. Space had no beginning. It was infinite from the start. This is philosophically important because it means asking, what's outside? The infinite universe is confused. Space extends infinitely in spatial directions, but time extends finitely into the past, to the Big Bang, and infinitely into the future. So the universe is infinite in space, but finite in past duration and infinite in future duration. This has implications for what time means. Time isn't something external to the universe that existed before the Big Bang. Time is part of space-time, which was created at the Big Bang. Before the Big Bang, there was no time. The question, what happened before the Big Bang, is nonsensical because there is no before. Time didn't exist. Similarly, in the far future, after heat death, time will continue. But without events or entropy changes, what does time even mean? Time is usually defined relative to change. In a static heat-death universe, time might be a meaningless concept, but mathematically, space-time continues. Coordinates in space-time extend infinitely. So even though time becomes trivial in the far future, space-time itself remains infinite. An infinite universe in space, finite in past time, infinite in future time. This is the cosmological picture that modern physics suggests. There's a subtle but important point about cosmic expansion in an infinite universe. The universe is expanding. Distances between distant galaxies are increasing. But does expansion affect an infinite universe differently than a finite universe? In a finite universe, expansion means the finite universe is getting bigger. It's stretching. In an infinite universe, expansion means an already infinite space is becoming more infinite. That doesn't quite make sense. Actually, what expansion means in an infinite universe is that the density of matter is decreasing. As space expands, the same amount of matter is spread over greater volumes. The universe becomes less dense. This happens everywhere simultaneously. Every observer sees themselves at the center of expansion because they're observing the universe isotropically from their location. And every observer sees distant galaxies receding. In an infinite universe, this means matter that was denser in the past is becoming sparser now. And in the infinite future, matter will be incredibly sparse, spread infinitely thin across infinite space. But there's still infinite matter. Assuming the universe started infinite, it's just distributed across an even larger infinity. This raises a question. If space is infinite and expanding, is there a meaningful sense in which the universe is getting bigger? Mathematically, yes. The scale factor, the expansion rate, increases with time. Distances between stationary galaxies increase. But if space was already infinite and it remains infinite, then in some sense, size becomes a misleading concept. You can't say an infinite thing is getting bigger because infinity plus infinity equals infinity. What's really happening is that the universe is becoming less dense and the scale factor is increasing. But these are local phenomena. Globally, an infinite universe remains infinite before and after expansion. This illustrates how infinity breaks intuitions about growth and change. Something infinite can't grow in the usual sense. It can transform, become denser or sparser, but not get bigger. This has implications for thinking about the universe's evolution. When we say the universe is expanding, we mean space is stretching, distances are increasing, density is decreasing. But we're not really describing growth of something infinite. We're describing a change in the scale and density of an infinite structure. If space is infinite, can we ever know it with certainty? Observationally, the answer is probably no. We can only observe what's within our cosmic horizon, 46 billion light years away. Beyond that, we're blind. We can't see farther, no matter how good our telescopes become. We could, in principle, map every galaxy within the observable universe, measure every distance, and document every structure. But that's finitely much information about a potentially infinitely large whole. It's like trying to determine if an ocean is infinite by measuring a bucket of water. The bucket's contents might be consistent with an infinite ocean, but you can't determine infinity by measuring finitely much. However, there are indirect ways to constrain whether space is infinite. We can measure the geometry of space-time using the cosmic microwave background. If space is positively curved, it's finite. If it's flat or negatively curved, it's likely infinite, or very large and flat. We can search for signs of wraparound in the cosmic microwave background. In a finite toroidal universe, we might see our own galaxy's light coming from different directions. We can measure the ages and distances of the farthest galaxies to infer how long the universe has been expanding and the rate of expansion. We can study the distribution of matter and test whether it's consistent with an infinite homogeneous distribution. All these tests, done carefully, can constrain whether the universe is finite or infinite, but they probably can't give a definitive proof either way. We might eventually conclude that space is almost certainly infinite or almost certainly finite based on probability arguments. But we may never achieve absolute certainty. This is philosophically interesting. Here's a fundamental question about the nature of reality. Is space infinite or finite? And we may never definitively answer it through observation. It highlights the limits of scientific knowledge. Science can measure and test and infer, but some questions might be forever beyond our observational reach, constrained by the structure of space-time itself. If space is infinite, if there are infinitely many copies of you, if every possible configuration of matter exists somewhere, where does that leave meaning? This is perhaps the deepest question raised by an infinite universe. In a finite universe with rare conscious observers, individual consciousness might matter more. Your thoughts, your experiences, your consciousness, these might be cosmically significant because they're rare. But in an infinite universe, consciousness might be commonplace. Infinitely many conscious beings, infinitely many experiences, infinitely many perspectives. Your consciousness is one of infinitely many. Does that make your experience meaningless? I don't think so. But I understand why someone might think so. Here's a perspective. Meaning might not be cosmic or objective. Meaning might be inherently personal and subjective. Your experience matters to you, regardless of whether there are infinitely many other experiences happening elsewhere. The fact that you're conscious right now having this experience that's real from your perspective, meaning might consist in how you respond to existence, what you do with your consciousness, how you treat others, what you create, learn, and share. An infinite universe doesn't erase any of that. It just provides a context where cosmic rarity doesn't confer special importance. Instead of seeking meaning in being special or unique, you might find meaning in being part of something vast. You're one conscious being in an infinite cosmos. That alone is extraordinary. Think about it. You're made of atoms forged in stars billions of years ago. You're part of a cosmic process that's been unfolding for 13.8 billion years. You're conscious at a moment when stars still shine and complexity still exists. The vastness of space and time doesn't diminish your significance. It contextualizes it. You're small, yes, but you're conscious. You're part of the universe observing itself. That's meaningful regardless of whether infinitely many versions of you exist elsewhere. If space is infinite, what does that mean for the future of intelligent civilization? A civilization that develops space travel might eventually expand beyond their home star system, then their home galaxy. Given enough time, billions or trillions of years, they might spread across vast regions of space. But in an infinite universe, even rapid expansion has limits. A civilization can only reach regions that are causally connected to them, regions whose light could have reached them, or where they could send signals. The cosmic horizon extends, so civilizations that expand fast enough can reach distant parts of space. But in an infinite universe, they can never reach the whole thing. There will always be regions infinitely far away that they can never access. This creates a strange picture of an infinite universe populated by isolated civilizations, each occupying a finite island of space surrounded by infinite emptiness. Over trillions of years, a civilization might populate a region billions of light years across. But the universe is infinitely large. Their occupied region would be vanishingly small, like a single grain of sand on an infinite beach. This raises questions about the long-term fate of civilization. Do they eventually give up expanding? Do they turn inward, focusing on their home region? Do they continue trying to expand, knowing they'll never reach the whole universe? Or do they develop such advanced technology that they find ways to transcend spatial limitations? Build wormholes? Manipulate space itself? These are speculative questions without clear answers. But they illustrate how infinity changes our understanding of civilization's potential. In a finite universe, a civilization might dream of eventually exploring and understanding the whole thing. In an infinite universe, that dream is impossible. They can explore and understand their local region, but the cosmos as a whole remains infinite and inexhaustible. An infinite universe raises several paradoxes, apparent contradictions that arise from applying finite intuitions to infinity. One is the paradox of infinity minus infinity. If space is infinite, it contains infinitely much matter. But as expansion continues, density decreases. Eventually, matter might become infinitely sparse. Infinitely much matter divided by infinitely much volume equal what? Zero? Indeterminate? Mathematically, we have techniques for handling this. We use limits and careful definitions, but conceptually it reveals how infinity breaks intuitions. Another paradox, the infinite Boltzmann brain problem. In an infinite universe with infinite time, random quantum fluctuations will eventually create conscious beings spontaneously from the vacuum. This means that future civilizations won't necessarily descend from our universe's initial matter. They might be created de novo by quantum fluctuations. How many such beings would there be? Infinitely many. How many would have our exact memories and experiences? Infinitely many. Does this mean you might wake up tomorrow as a spontaneously created Boltzmann brain with false memories? Mathematically, this is possible. Philosophically, it's unsettling. It suggests personal identity becomes meaningless if infinitely many beings can have your exact thoughts and memories. Another paradox, the infinite regression problem. In an infinite universe, there are infinitely many regions. In each region, there might be different physical laws in some multiverse models. So why do we observe the particular laws we do? One answer, we're necessarily in a region where laws permit our existence. But in an infinite multiverse, there are also infinitely many regions where we wouldn't exist. Why don't we observe those instead? This is a form of the anthropic principle applied to infinity. Our observation of our laws is guaranteed by the fact that we're in a region with those laws. But it raises questions about whether we're asking well-formed questions when we apply probability to infinities. These paradoxes don't prove the universe isn't infinite. They just show that infinity is hard to think about. Our intuitions fail. Mathematics must guide us. I've been contemplating infinity since I was 15 years old, and I still find it overwhelming. But over the years, my relationship with the concept has evolved. At first, infinity was terrifying. It seemed to erase meaning, to make my existence insignificant. But gradually, I've come to find something beautiful in it. If space is infinite, then the universe is larger and more complex than my mind can grasp. That's humbling, but it's also liberating. It means I don't have to understand everything. I can focus on what's comprehensible: my local region, my life, my world. Everything beyond the cosmic horizon is beyond my reach, so I might as well accept it and focus on what I can know. It means there might be infinitely many conscious beings thinking their own thoughts, having their own experiences. I'm one of infinitely many perspectives on an infinite cosmos. That's a kind of belonging. I'm part of something vast. It means I don't have to be special or unique to matter. Just being conscious, just being part of the universe observing itself is enough. An infinite universe doesn't require me to accomplish grand cosmic goals or leave a permanent mark on space-time. I can live my life, pursue my interests, connect with others, and that's meaningful because I'm doing it. I think if space truly is infinite, if we eventually collect enough data to conclude that's the case, humanity will undergo a profound shift in perspective. We'll realize we live in a cosmos so vast that our cosmic horizon is utterly negligible. We'll understand that civilizations might exist infinitely far away, beyond our reach. We'll grasp that the universe is structured in ways that make unity or contact between civilizations virtually impossible. And we'll have to decide, does that make existence meaningless? Or does it make our existence, our consciousness, our connections, our ability to think and understand all the more precious? I believe it's the latter. An infinite universe makes consciousness more precious, not less, because consciousness in an infinite void is miraculous. Modern cosmology has developed several mathematical models of the universe, and some of them naturally lead to infinite space. The standard model of cosmology, called lambda CDM, lambda cold dark matter, describes a flat, spatially infinite universe undergoing accelerated expansion due to dark energy. But there are alternatives. Cyclic models propose the universe goes through endless cycles of expansion and contraction. Eternal inflation models propose that inflationary expansion never fully stops. Some regions continue inflating while others form stable universes like ours. In eternal inflation, space is effectively infinite. New universe regions are constantly being created in distant regions while existing regions cool and evolve. This creates a kind of infinite multiverse where our Big Bang was just one of infinitely many occurring in different space-time locations. String theory, another leading theoretical framework, suggests there might be 10 to the power of 500 different possible vacuum states, different configurations of the cosmos with different physical laws. If only a small fraction of these are populated, we still get a vast but finite multiverse. But if eternal inflation is correct and vacuum states can transition between different values, we might get infinite multiverse with all possible laws represented infinitely many times. The point is, several well-motivated theoretical models lead to spatial or mathematical infinities. This isn't proof that space is actually infinite. Theoretical models are just that, models. They might or might not reflect reality, but it shows that infinity isn't some crazy idea invented by philosophers. It's a natural consequence of taking seriously the mathematics of modern cosmology. If we believe general relativity, if we believe inflation, if we believe some form of eternal inflation is correct, then infinity follows. Of course, inflation might be wrong. String theory might be wrong. Eternal inflation might not occur. But current evidence and theory point toward infinity as a possibility worth taking seriously. Here's a question nobody asks but should. What are the ethical implications of an infinite universe? If space is infinite and physical laws are the same everywhere, then infinitely many conscious beings exist, infinitely many suffering, infinitely many joy, infinitely many moral agents and patients. Does that change ethics? Some philosophers argue yes. If there are infinitely many conscious beings, then moral actions affecting just finitely many might seem insignificant. Preventing one being from suffering doesn't matter much if infinitely many others are suffering. Oh, others argue ethics is relative to the agent's perspective. Even if infinitely many beings exist, the beings I can affect are finite and local. My moral obligations are to them, not to the infinite whole. There's also a question of moral weight. Does a being in a distant galaxy have the same moral status as a being I can affect? Most ethicists would say yes. All conscious beings matter morally, regardless of distance. But in an infinite universe, some beings are causally disconnected from me. I can never affect them, never help or harm them. What moral obligations do I have toward beings I can't possibly interact with? These are open questions in philosophy, but they illustrate how infinity raises new ethical puzzles. There's also a question about purpose. If the universe is infinite and existence will eventually reach heat death after unfathomable timescales, what's the purpose of consciousness? Some people find this depressing. What's the point of suffering, creating, loving, learning if the universe eventually becomes empty and cold? Others find it liberating. If the universe has no cosmic purpose, then we're free to create our own purpose. We can decide what matters, what's meaningful, what's worth doing. An infinite universe doesn't dictate ethics. It just provides the context. Within that context, beings still make choices, still treat each other with care or cruelty, still create meaning. I've spent this whole video exploring what an infinite universe means. But let me also consider the alternative. What if space isn't infinite? A finite universe has its own profound implications. If space is finite but unbounded, like the surface of a sphere, then you can travel in a straight line and eventually return to where you started. You don't hit a wall. Space just wraps around. This solves the edge problem. There's no edge. The universe is closed in on itself, but it raises other questions. Why is the universe finite? Is finiteness a fundamental feature of space-time, or just a contingent fact about our cosmos? A finite universe also changes cosmology. If space is finite, the total amount of matter is finite. The observable universe might be a significant fraction of the whole universe. If the universe is finite and much larger than the observable universe, there could be regions beyond our cosmic horizon that we can never see. But at least the universe has a definite size, even if we can't measure it. Some philosophers actually prefer a finite universe. It seems more complete somehow. A finite universe has a total size. An infinite universe is open-ended without a definite magnitude. But mathematically, both are consistent with general relativity. Both raise philosophical questions. Both are possible. Current observations can't definitively distinguish between them. We can say space is approximately flat. We can say the observable universe is approximately homogeneous. But we can't say with certainty whether space is infinite or finite. This ambiguity is actually profound. One of the most fundamental questions about reality, is space infinite or finite, might not have an answer we can determine through observation. We might gather more and more data, refine our measurements, and still not know. Eventually, we might have to accept that the universe's finiteness or infiniteness is fundamentally beyond our ability to determine. We'd know a lot about our cosmic region, but not whether it's part of a larger whole or the whole itself. After all this exploration of infinity, where does that leave us? The honest answer, we don't know if space is infinite. Current evidence is consistent with infinity, but it doesn't prove it. Observations might eventually demonstrate infinity's impossibility, or they might confirm it, or they might remain forever ambiguous. So we live with uncertainty about one of the most fundamental features of reality. How do we do that? I think by accepting that certainty about everything isn't possible. Science can tell us a lot about the universe. But some questions remain open. Some mysteries might remain forever. An infinite universe is beautiful precisely because it's beyond our complete comprehension. We can understand its structure, its history, its physics, but we can't grasp its totality. That totality exceeds finite minds. And that's okay. In fact, it's wonderful. The universe would be boring if we could fully understand it, completely map it, fully explain it. An infinite universe is inexhaustible. There's always more to learn, more to discover, more to contemplate. If space is infinite, then consciousness has infinite work to do. The universe will never be fully understood. There will always be mysteries, always questions, always new frontiers. For those of us who find meaning in exploration and understanding, infinity provides endless opportunity. For those who find meaning in connection and community, infinity raises the poignant possibility that we're isolated. Our civilization confined to a finite region, separated from infinitely many others by distances we can never traverse. Both perspectives are true. Infinity is beautiful and limiting, transcendent and isolating, inspiring and overwhelming. I think the key is to hold both perspectives simultaneously, to marvel at the size of the universe while also finding meaning in local actions and connections, to accept our insignificance while celebrating our consciousness. That's what it means to live in an infinite cosmos, to be small and aware, to be limited yet capable of understanding those limits. That's enough. That's everything. Humanity's relationship with infinity has a long history. In ancient Greece, philosophers like Zeno created paradoxes of infinity. Achilles and the tortoise. If the tortoise has a head start, can Achilles ever catch it? He'd need to first close half the distance, then half of that, then half of that. Infinitely many intervals. How can he traverse infinitely many intervals in finite time? Zeno's paradoxes troubled thinkers for centuries. They seemed to show that motion was impossible. But they were resolved by calculus and the concept of infinite series converging to finite sums. In the Middle Ages, theologians debated God's nature. Is God infinite? Can God create an infinite universe? Can infinities exist or only God? In the Renaissance and early modern period, mathematicians began treating infinity more seriously. They developed techniques for working with infinitesimal quantities and infinite series. Newton and Leibniz developed calculus, which relies on infinite processes, taking limits of infinite sequences, integrating by dividing into infinitely many pieces. In the 19th century, Cantor developed set theory and showed infinities come in different sizes. This made infinity precise and mathematically tractable. In the 20th century, cosmology emerged as an observational science. Astronomers began measuring cosmic distances and asking, does the universe have an edge? Is it infinite? Currently, we know more about the universe's size than ever before. We know it's at least 46 billion light years across. We know it's probably either infinite or so large that the difference doesn't matter. But we still don't know definitively. What's remarkable is how the question persists. From ancient philosophers to modern cosmologists, the question of infinity remains central. It's not just a mathematical question. It's a question about the nature of reality, about our place in the cosmos, about what existence means. If space is infinite and conscious beings emerge with some probability, then there are infinitely many conscious minds thinking, experiencing, reflecting. What does that mean? For one thing, it means consciousness is probably commonplace in the universe. Not rare, not unique, just one phenomenon among infinitely many. That might seem depressing. Your consciousness is just one of infinitely many. Your thoughts are echoed infinitely many times across space. But consider the inverse. There are infinitely many conscious beings, infinitely many minds contemplating existence, infinitely many perspectives on reality. That's kind of wonderful. The universe isn't a cold, empty void. It's teeming with consciousness. There's an infinite chorus of minds thinking, wondering, experiencing. You're part of that. Your consciousness is part of an infinite phenomenon. You're one voice in an infinite choir. Some philosophers find comfort in that. You're not alone. Infinitely many beings share your fundamental nature, consciousness, awareness, the capacity for wonder. Others find it isolating. Despite infinitely many conscious beings existing, you're isolated from almost all of them. You'll never meet them, never know them, never share experiences with them. The vast distances of space ensure isolation. Beings in distant galaxies are causally disconnected. They might exist, but they're effectively invisible and unreachable. So maybe consciousness is simultaneously common and isolated, infinitely many minds, infinitely separated. That's a peculiar situation. It's both connecting and lonely. But it raises questions worth thinking about. If infinitely many conscious minds exist, do their collective experiences matter? Does the universe care that it's conscious in so many places? Or is consciousness just a local phenomenon, important to the beings experiencing it, but cosmically insignificant? These are unanswerable questions, but they emerge naturally from contemplating an infinite universe with infinite consciousness. Let me lay out some specific, concrete implications if space turns out to be infinite. First, the observable universe is infinitesimally small. The 46 billion light year sphere we can observe is just the tiniest fraction of an infinite whole. Every observation we make, every measurement, every astronomical data point, it's all from this infinitesimal bubble. Second, physical laws are almost certainly the same everywhere. An infinite universe that's homogeneous means the same physics applies everywhere. That's comforting. It means our understanding of natural law is universal. Third, life and consciousness are probably common. An infinite universe with even a tiny probability of life means infinite life. Consciousness is probably spread throughout space in infinitely many instances. Fourth, civilizations are probably isolated. Despite abundant life and consciousness, the distances are so vast that civilizations can't contact each other. The Fermi Paradox finds a natural resolution in the sheer size of space. Fifth, the universe will never be fully explored or understood. No civilization, no matter how advanced, can explore an infinite universe. There will always be farther regions, always mysteries beyond the next horizon. Sixth, meaning must be created locally. Since cosmic unity is impossible, meaning must be built in small communities, personal relationships, local efforts. The infinite cosmos provides no grand purpose. Seventh, time continues forever. Space is infinite. Time is infinite in the future. The universe will exist for trillions of years after we're gone, and trillions more after that, unto infinity. Eighth, nothing lasts forever on cosmic scales. Stars burn out, black holes evaporate, civilizations rise and fall. In an infinite universe lasting infinite time, everything impermanent eventually passes away. These implications are both liberating and constraining. They free us from the need to understand everything or save the cosmos. They constrain us to find meaning locally rather than seeking cosmic significance. I've mentioned the many worlds idea several times. Let me explore it more deeply. The many worlds interpretation of quantum mechanics suggests that every quantum event creates branching universes. When a quantum system has multiple possible outcomes, all outcomes actually occur in different branches of reality. If true, this creates an incomprehensibly vast branching structure. Every conscious being experiences one particular branch, But infinitely many other branches exist where they make different choices or experience different outcomes. Combined with cosmic inflation and an infinite universe, this creates a picture of infinite multiverse with infinite branching. Imagine in your present moment, you're at a particular location in the branching tree of universes. You're experiencing one particular sequence of outcomes, but infinitely many branches diverge from your past, leading to alternate versions of you with different histories. And infinitely many branches diverge from your present, leading to futures where you make different choices. In this framework, all possible experiences are realized somewhere. Every choice is made, every possible life is lived. This has disturbing implications for personal identity and free will. If all choices are made, does your choice matter? Some say yes, it matters to you. From your perspective, your subjective experience of choice is real, even if other versions of you are choosing differently. Others argue this makes free will illusory. If all possible choices are realized anyway, you might as well have no choice at all. This connects to an ancient philosophical problem. If God is omniscient and knows your future choices, do you have free will? Similarly, if the many worlds interpretation is correct and all possible futures exist, do you have free will? The answer might be perspective dependent. From an outside view looking at the branching tree, all futures exist and your choice is deterministic. It follows from quantum mechanics. But from your inside perspective, experiencing one branch moment by moment, your choices feel free and undetermined. Both perspectives might be true simultaneously. This is the promise and the puzzle of many worlds. It resolves the quantum measurement problem, but raises profound questions about the nature of experience and choice. How do scientists approach questions about infinity when infinity can't be directly observed? The method is indirect. We observe what we can and infer properties we can't observe. For instance, we measure the cosmic microwave background radiation with extraordinary precision. We analyze the temperature fluctuations. We compare observations to theoretical predictions for different universe geometries. If space is positively curved, the CMB would have certain statistical patterns. If space is flat, it would have different patterns. If space is negatively curved, yet different patterns. By carefully analyzing the CMB, we can constrain the curvature of space. Current measurements suggest space is very close to flat, but with uncertainties. Similarly, we measure the expansion rate of the universe using distant supernovae. We measure the ages of distant galaxies. We study the large-scale structure of matter. All these observations constrain models of the universe. We can test predictions of different models and see which fit the data best. But here's the key. Even if all observations are consistent with an infinite universe, we can't definitively prove infinity through observation. Infinity lies beyond our cosmic horizon. We can only constrain it through indirect methods. We can accumulate evidence. We can make it more or less likely, but we probably can't achieve absolute certainty. This highlights a deep issue in science. Some questions might be beyond the reach of observation, even in principle. An infinite universe is defined partly by what's beyond our observable reach. We can never observe infinity because observation requires light to reach us, and we only observe things within our cosmic horizon. This is a fundamental limit to observational science. Some questions about reality might not be answerable through observation. Science can still address them theoretically through mathematical consistency and philosophical reasoning. But empirical proof might be impossible. That's okay. Science has always operated within such limits. We ask questions we can investigate. Some questions remain forever open. After all this exploration, after considering infinitely many copies of ourselves, infinitely many conscious beings, infinitely many civilizations spread across infinite space, what's left to say? I think it's this: infinity is real, not as a number, not as something we can measure or count, but as a genuine possibility about the structure of reality. And if infinity is real, we have to take it seriously. We have to grapple with what it means. It means we're possibly smaller and more isolated than we ever imagined. It means there might be infinitely many conscious minds thinking thoughts we'll never know. It means the universe is vast beyond any scale we can truly grasp. But it also means we're part of something genuinely infinite and eternal. It means consciousness itself might be an infinite phenomenon. It means the story of the universe is without end. An infinite universe is challenging to contemplate. It resists intuition. It breaks our mental models. It makes our certainties seem fragile. But facing infinity, really facing it, not just acknowledging it intellectually, but feeling its weight, might be one of the most important things consciousness can do. Because in confronting infinity, we confront our own limits. We acknowledge that our minds can't grasp everything. We accept that mystery persists. And in accepting limits, we might find freedom. Freedom from needing to understand everything. Freedom to focus on what we can know and do. Maybe that's the ultimate message of an infinite universe. Be here now. Understand what you can. Connect with others in your local region. Create meaning through relationships and growth and wonder. The infinite cosmos continues whether or not you understand it, but your life, your consciousness, your connections to others, these are real and valuable precisely because they're finite and limited. Infinity provides the context. Finitude provides the meaning. Let me explore some of the weird logical properties of infinity that make it so hard to think about. In a finite set, you can ask how many elements. You can count them, list them, compare the count to other sets. In an infinite set, these questions become problematic. How many elements in the set of all integers? Infinitely many. How does that compare to the set of all real numbers? Also infinitely many. But the reals are more infinite than the integers. There's no way to create a one-to-one correspondence between them. So infinities have different sizes, but you can't compare them in the simple way you compare finite quantities. Another strange property: in an infinite set, you can remove infinitely many elements and still have an infinite set of the same size. The set of all integers minus all even integers is still countably infinite. How can removing infinitely many leave you with an infinite set of the same size? Because infinity plus infinity, or infinity minus infinity, doesn't follow normal arithmetic rules. Another: if you have two infinite sets of the same size and you combine them, you get an infinite set of the same size, not twice as big. This violates our intuitions about addition. Combining two things usually makes them bigger, but combining two countably infinite sets gives you a countably infinite set. These strange properties make infinity behave unlike finite quantities. Infinity isn't just a really big number, it's a different category of thing. An infinite universe has these same strange properties. You can have infinitely many galaxies, infinitely many stars. But the total is still just infinity. Add infinitely many more regions, still infinity. You can remove large portions of infinite space and still have infinite space. Infinity is so vast that removing finite amounts doesn't reduce it. Understanding this requires letting go of finite intuitions. Infinity isn't just a magnitude, it's a different mode of existence. If space is infinite, what should humanity do about it? First, accept it. The universe is what it is. Whether space is finite or infinite, we should accept reality as we discover it. Second, find meaning despite infinity. Infinity doesn't erase meaning, it contextualizes it. Our lives are still meaningful even in a cosmos vastly larger than we are. Third, focus on the local. Since infinite space probably means civilizations are isolated, humanity should build strong local communities, create connections with others on Earth, build communities that can sustain themselves. Fourth, continue exploring and understanding. Even if we can't explore the whole universe, we can explore our local region. There are billions of star systems within reach in principle. Centuries or millennia of explorations await. Fifth, preserve knowledge. In an infinite universe, the future is very long. Knowledge that survives might eventually be useful. Culture that persists might eventually matter. Sixth, accept mortality. Civilizations rise and fall. Species go extinct. In an infinite universe with infinite time, even the most successful civilization will eventually end. That's okay. Impermanence doesn't negate meaning. Seventh, seek others. Even though civilizations are probably isolated by vast distances, the search for alien intelligence is worth continuing. The possibility of contact, however remote, is worth pursuing. Eighth, be humble. An infinite universe teaches humility. We're not the center, we're not special. We're one small perspective in an infinite cosmos. But humility doesn't mean despair. It means recognizing our limits while still acting within them. It means understanding our place while still creating meaning. Living with the knowledge that space might be infinite changes how we experience existence. When you look at the night sky and think, space is possibly infinite, something shifts. The stars aren't just distant objects, they're markers of an abyss of space that might go on forever. You're standing on a planet orbiting a star in a galaxy among billions, in a universe that might be infinitely large. That can feel disorienting, it can feel insignificant, but it can also feel liberating. If space is infinite, then there's no cosmic destiny for humanity. There's no ultimate purpose we're failing to achieve. We're not special, but neither is anyone else. That means we're free to create our own purpose. We don't need to achieve cosmic significance. We just need to live lives that are meaningful to us and to those around us. An infinite universe removes the burden of needing to be important to the cosmos. It frees us to find importance locally. An infinite universe also creates a kind of awe that finite-minded creatures like us rarely experience. The sheer scale of potential existence, infinitely many stars, infinitely many worlds, possibly infinitely many minds, creates a wonder that transcends normal experience. That wonder can be valuable. It can inspire exploration, growth, curiosity. It can make us feel part of something much larger than ourselves, but it can also be overwhelming. Some people respond to cosmic scale with despair. If I'm so small, if space is so vast, what's the point of anything? I think the answer is that meaning and purpose are constructed locally. You create meaning through relationships, through work, through growth and understanding. The infinite cosmos provides the backdrop, but your meaning is created by you and those around you. An infinite universe is a strange place to live, but it's the place we actually live. And living here, creating meaning here, connecting with others here, that's what matters. If space is infinite, what are the technological implications for future civilizations? First, interstellar travel becomes even more challenging. The distances between stars are already vast. Even reaching Alpha Centauri would take centuries with current technology. In an infinite universe, the number of reachable stars is still effectively limited by the speed of light and the lifespan of civilizations. A civilization might explore a sphere of space 1,000 light years across, an enormous volume containing millions of stars, but in an infinite universe that's still infinitesimally small. There will always be infinitely much unexplored space. This might drive development of new technologies, faster than light travel, if possible, suspended animation for centuries long journeys, space based habitats that sustain civilizations indefinitely. But even with advanced technology, the limits of an infinite universe remain. You can never visit everything. You can never reach the end. Some might argue this creates a futility. Why explore when there's infinitely much to explore? Why expand when expansion never covers the whole universe? Others see opportunity. If space is infinite, exploration never ends. The frontier is infinite. The opportunity for growth, discovery, and expansion is literally endless. Second, communication across space becomes important. If civilizations are isolated by vast distances, even more than we thought, then advanced communication technologies might become crucial, sending signals across billions of light years to detect other civilizations. The technology for this might never be developed. The distances might be too vast, but the attempt would be worthwhile to break the isolation. Third, self-sufficiency becomes critical. If a civilization can't count on ever reaching others, they must be able to sustain themselves indefinitely. That requires closed-loop life support, renewable energy, sustainable resource management. Fourth, knowledge preservation becomes paramount. In an infinite universe, knowledge that doesn't survive is lost forever. A civilization should create multiple copies of important knowledge, distribute it across space, ensure it survives for as long as possible. Fifth, cooperation within solar systems becomes the default. If you can't reliably contact distant stars, you should focus on stable relationships with neighbors within your solar system. An infinite universe shapes the technological and social development of civilizations. It encourages self-sufficiency, knowledge preservation, and local cooperation. I started this video with a 15-year-old me lying in bed struck by the thought of infinity. What would that version of myself think if he knew infinity might be real? I think he'd be both terrified and awed. Terrified because infinity is overwhelming, awed because the universe is even bigger than he imagined. The adult me has learned to live with infinity. I don't think about it constantly anymore. Most days, I'm caught up in immediate concerns: work, relationships, daily life. But sometimes, usually at night, I'll think about the scale of space. I'll consider that right now, infinitely far away, there might be conscious beings thinking their own thoughts, making their own discoveries. And I feel connected to that, not because I can reach them, I probably never will, but because we're all part of the same universe. We're all manifestations of the same fundamental reality. An infinite universe is lonely in that way. It separates us from others, but it also connects us all to something vast and eternal. If space is infinite, then I'm living in an infinite cosmos. So are you. We're embedded in something that exceeds comprehension, something so large it dwarfs everything we know. But we're here, conscious, aware. We can think about our cosmic context. We can wonder. We can create meaning. That's what humanity should do with the knowledge that space might be infinite. not despair at insignificance, but marvel at being conscious witnesses to an infinite cosmos. Not give up on creating meaning, but create meaning anyway, locally and personally. Not stop exploring and understanding, but continue, knowing the work never ends. An infinite universe is a challenge to human meaning making, but it's also an invitation to think deeply, to wonder greatly, to build connections with others while acknowledging the vastness that separates us. If space is infinite, we're all floating on islands in an infinite sea, but we're floating together, and that's enough. Here's a philosophical question that infinity raises. If something is infinitely far away and causally disconnected from us, does it really exist in any meaningful sense? This touches on a philosophical concept called operationalism, the idea that something only exists if we can observe or measure it. An electron has properties only when measured. Before measurement, it's in a superposition of states. Does the electron have definite properties before measurement? Similarly, the universe beyond our cosmic horizon, does it exist in a definite state or only in potential? Some philosophers argue that the universe beyond our observable horizon might as well not exist. From a practical perspective, we can never interact with it. It can never affect us. It doesn't enter into our physics or our observations. From this view, the universe is effectively finite. It extends only as far as we can observe or, in principle, affect. Others argue that the universe exists independently of whether we observe it. Just because we can't see beyond the horizon doesn't mean there's nothing there. This connects to long-standing philosophical debates about the nature of reality. Is reality observer-dependent? Idealism? Or does reality exist objectively, independent of observers? Realism. Modern physics suggests reality is observer-dependent at quantum scales. Measurements affect outcomes. But at large scales, the universe seems to exist independently of any observer. An infinite universe beyond our observation horizon raises the question, what's the status of that infinity? If it exists, but we can never observe or interact with it, how different is that from not existing? Philosophically, it might not matter. What matters is what we can observe and affect. The universe beyond our horizon is effectively irrelevant to our lives. But cosmologically, it matters a lot. An infinite universe has different properties, different entropy, different long-term fate than a finite universe. And psychologically, it matters. Just knowing that infinity might exist beyond our horizon changes how we think about our place in the cosmos. To truly understand infinity in cosmology, we need to understand the mathematical frameworks physicists use. General relativity describes space-time as a four-dimensional manifold, a mathematical structure that locally looks like flat four-dimensional space, but can curve in complex ways. A manifold can be finite or infinite. It can be bounded, having an edge, or unbounded, no edge. These are independent properties. You can have finite unbounded, like a circle, or infinite unbounded, like an infinite line. Our universe is believed to be a manifold that's either finite unbounded or infinite unbounded, not finite bounded because there's no evidence of an edge. Mathematically, an infinite manifold is described using limits. As you add more and more space, the total becomes infinite in the limit, but infinite manifolds have paradoxical properties. For instance, an infinite manifold has infinite volume, infinite surface area, and other infinite measures. But you can have infinite manifolds where certain geometric properties are still well defined. Cosmology uses techniques from differential geometry to describe curved spacetime. The Friedman equations, which describe cosmic expansion, assume a homogeneous, isotropic universe, the same everywhere and in all directions on large scales. These equations have solutions for both finite and infinite universes. A finite universe solution has the universe curving back on itself. An infinite solution has the universe extending forever. Both solutions are mathematically consistent. Both can produce the observations we see in the cosmic microwave background and large-scale structure. The reason we can't distinguish between them observationally is precisely because they're both mathematically consistent. They're both compatible with general relativity and with observations. Understanding infinity in cosmology requires comfort with these mathematical abstractions. It's not enough to think about space extending forever in a colloquial sense. You need to understand how manifolds work, how differential geometry describes curvature, how limits and infinities behave mathematically. Physics provides the tools, but the intuition remains elusive. Infinity is fundamentally challenging for minds that evolve to think in finite terms. If space is infinite, it has implications not just for cosmology, but for the entire future of human and perhaps post-human thought. An infinite universe means that future minds, artificial intelligences, post-human intelligences, minds we can't yet imagine, will face the same fundamental mysteries we face. Infinity is not something that future knowledge will resolve. It's a fundamental feature of reality, if true, that will always exceed comprehension. This might seem depressing, but it's actually liberating. It means that intellectual progress never ends. There will always be mysteries, always new frontiers, always more to understand. For species or civilizations that aspire to unlimited growth and exploration, an infinite universe provides unlimited opportunity. The frontier never closes. For those seeking rest or completion, an infinite universe might seem frustrating. You can never finish exploring. You can never fully understand the cosmos. You can never reach an end. But perhaps that's the point. Perhaps an infinite universe is the only kind of universe compatible with eternal growth and eternal novelty. A finite universe, if we fully explored and understood it, might become boring. An infinite universe guarantees that surprise, mystery, and wonder persist eternally. Future post-human intelligences, thinking thoughts we can't think, might appreciate an infinite cosmos more than we do. They might develop concepts and frameworks we lack entirely. They might discover ways to traverse or manipulate space that we consider impossible. They might develop technologies that exploit quantum phenomena or space-time structure in ways we haven't imagined, but even with arbitrarily advanced technology, they'd still face the fundamental fact of infinity. They couldn't explore it all. They couldn't understand it completely. They'd be forever embedded in something larger than themselves. That's the human condition, too. We're embedded in a universe larger than ourselves. Our minds exceed our individual brains through technology and culture. But we're still limited. We're still finite. An infinite universe teaches us something about the nature of consciousness and intelligence. They're always limited, always embedded in something larger, always discovering new dimensions of what they don't yet understand. That's not a failure. That's the nature of intelligence, to reach beyond its current limits forever. So we return to where we started. I was 15 years old, and infinity changed how I thought about existence. Decades later, I still think about it. I still find it overwhelming and beautiful in equal measure. If space is infinite, and current evidence suggests it might be, then we live in a cosmos so vast that our entire cosmic history is invisible within it. We're embedded in something that exceeds our comprehension, but we're here anyway, conscious, aware, capable of thinking about our cosmic context. That's the miracle. That's what makes an infinite universe worth contemplating. Not that it diminishes us, but that within its vastness, consciousness can still emerge and contemplate. We're not just observers of infinity, we're part of it, finite parts of an infinite whole. The question, what if space is infinite, is really the question, what does it mean to exist in an infinite cosmos? And the answer is, it means you're part of something eternal and incomprehensible. It means your life is meaningful not because it changes the cosmic order, but because of causally influence. Causality applies. Outside your light cone, causality is inaccessible. In an infinite universe, most of the universe is outside your causal reach. You can never interact with the vast majority of it. This has philosophical implications. If you can't causally interact with something, does it matter whether it exists? Some philosophers argue it doesn't matter. If the universe beyond your cosmic horizon can never affect you, then from your perspective, it might as well not exist. Others argue existence is independent of causality. Something can exist without affecting you. This touches on fundamental questions about the nature of reality. Is reality defined by what can be observed or causally affected? Or does reality exist independently? For a truly infinite universe, this becomes unavoidable. You must accept that vast regions exist beyond your causal reach. You must accept that causality is limited in scope. This changes how we think about cosmic history. The Big Bang created not just our observable universe, but potentially infinitely much more that we can't access. The history of those distant regions is causally independent of our history. They have their own past, their own evolution, their own outcomes. An infinite universe is not just infinitely large, but causally fragmented. Infinitely many separate causal zones, evolving independently, inaccessible to each other. That's a strange and profound implication of infinity that's rarely discussed. Infinity doesn't just mean space is large, it means causality itself is localized. Reality splits into infinitely many causally separate domains. Earlier, I mentioned heat death, the eventual state of maximum entropy. Let me explore this more deeply for an infinite universe. In a finite universe, heat death is absolute. All energy gradients fade. All stars burn out. All structure dissolves. After timescales of 10 to the power of 100 years or more, nothing interesting remains. Just a cold, dead expanse of particles at equilibrium. But in an infinite universe, heat death takes on a different character. An infinite amount of energy dissipates over an infinite amount of time. The universe becomes infinitely cold and sparse, but it never truly reaches zero temperature or zero activity everywhere. Quantum fluctuations continue forever. These fluctuations might occasionally create brief pockets of complexity, atoms assembling randomly, then dissolving, living creatures forming by chance, then dying, minds emerging momentarily from quantum noise, then evaporating. In an infinite universe with infinite future time, every quantum fluctuation that's possible will occur, infinitely many times. This includes fluctuations that create conscious beings. These Boltzmann brains would emerge spontaneously from the quantum vacuum, have a brief conscious experience, then dissolve back into chaos. Some of these brains might have memories of histories they never experienced, false memories created by quantum accident. A Boltzmann brain might think it has a lifetime of memories, but it just came into being moments ago. This raises a disturbing question. Might you yourself be a Boltzmann brain? Might you have appeared spontaneously from quantum fluctuations with false memories of a past that never happened? Statistically, if Boltzmann brains vastly outnumber brains that evolved naturally, you're more likely to be a Boltzmann brain than a real human with a real history. This is called the Boltzmann brain problem or the fluctuation problem. It's unresolved in physics. In a finite universe, the Boltzmann brain problem is less severe. Eventually, the universe reaches true maximum entropy. The probability of fluctuations approaches zero. The number of Boltzmann brains might be vast but finite. But in an infinite universe with infinite future, Boltzmann brains might be inevitable and infinite. This means the far future of an infinite universe is not empty and dead, but bizarrely alive with fleeting consciousness. Infinitely many minds blinking in and out of existence. Infinitely many moments of awareness scattered across infinite time. That's a strange and somewhat horrifying vision of the cosmic future, but it follows from taking infinity seriously. I've explored what it means if space is infinite. But what if our reasoning is flawed? What if space is finite and we just don't know it yet? This is worth considering seriously. Science has been wrong before. Our intuitions fail us in extreme regimes. For instance, quantum mechanics violates our classical intuitions. Relativity violates our intuitions about space and time. Perhaps infinity in cosmology violates our mathematical intuitions in ways we haven't recognized. There are actually some arguments that space should be finite, not infinite. First, quantum gravity considerations. At the Planck scale, 10 to the power of minus 35 meters, quantum effects dominate gravity. A quantum theory of gravity might reveal that space-time itself is quantized and discrete, making infinity impossible in the classical sense. Second, thermodynamic arguments. An infinite universe has infinite entropy. Some physicists argue that infinity causes paradoxes in statistical mechanics that wouldn't arise in a finite universe. Third, observational necessity. If we can only observe a finite region, perhaps infinity is unobservable in principle. Some argue we should only accept what's observable. By that standard, we should be agnostic about whether infinity exists beyond our reach. Fourth, fine-tuning reversal. An infinite universe seems to solve the fine-tuning problem. If infinite universes exist with all possible physical constants, obviously we find ourselves in one where life is possible. But some argue this is metaphysically extravagant. A simpler explanation: our universe is uniquely fine-tuned for reasons we don't understand. Fifth, simplicity arguments. Occam's razor suggests we should prefer simpler theories. A finite universe might be simpler than an infinite one, even if infinity follows naturally from inflation. These are good arguments worth taking seriously. They suggest infinity is not the only possibility. What if space is actually finite, but so vast that detecting its finiteness is impossible? What if the universe curves back on itself, but the curvature is so gentle that we can never measure it? If so, infinity might be an illusion. Space seems infinite from our limited perspective, but it's actually finite. This uncertainty should make us humble. We don't know if space is infinite or finite. Current evidence is consistent with both. Future evidence might prove us wrong about either assumption. That's okay. Science progresses through provisional answers and refined understanding. Right now, infinity is possible. The implications I've explored might apply, or they might not. Either way, contemplating infinity teaches us something valuable. The universe might be far stranger and more vast than we can imagine. If space is infinite, what should we aspire to? What goals are worth pursuing? Some might say if the universe is infinite, individual achievement is pointless. You can never explore it all. You can never change its fundamental nature. Why try? But I think that's the wrong conclusion. An infinite universe means your influence is local, but your wonder is eternal. You can't change the cosmos, but you can change your local region. You can build civilizations, create art, understand nature, connect with others. An infinite universe means the frontier never closes. For thousands or millions of years, there will be new places to explore, new phenomena to understand, new questions to answer. An infinite universe means your consciousness right now is participating in something eternal. The matter that makes you up was forged in stars. The laws that govern you will persist eternally. The fact that you're conscious in this moment is a local manifestation of a universal property. You're not insignificant because you're small. You're remarkable because you're conscious despite being small. An infinite universe is humbling. It tells us we're not the center. We're not special in a cosmic sense, but it's also liberating. It removes the burden of cosmic significance. It frees us to find meaning locally. If space is infinite, our task is not to understand or control the whole thing. Our task is to understand and improve our local region, to build communities, create knowledge, connect with others. Over timescales of thousands or millions of years, humanity, or whatever we become, might spread across the galaxy. We might create civilizations spanning light years. We might accumulate knowledge and technology beyond anything we can currently imagine. And none of that would be even remotely close to exploring or understanding an infinite universe. But that's okay. We don't need to control infinity to make our existence meaningful. An infinite universe is so vast that individual actions seem insignificant, but an infinite universe also ensures that significance is always possible. There's always room for growth, exploration, discovery. If space is infinite, then conscious existence, the fact that awareness and understanding emerge in this vast cosmos, is even more remarkable than we thought. You're part of that remarkability. Your consciousness is part of the universe's self-understanding. That's meaning enough. That's purpose enough. After all this exploration, mathematical infinities, cosmological implications, philosophical challenges, personal reflections, where do we stand? Here's what we know. The universe is very large. At least 46 billion light years across in all observable directions, probably containing hundreds of billions of galaxies, each galaxy containing hundreds of billions of stars. Most stars probably having planets around them. Here's what we don't know: whether this vast expanse continues infinitely beyond our cosmic horizon, whether space is truly infinite or merely very large and finite, whether physical laws are identical everywhere or vary in distant regions. Here's what we can infer. If space is infinite, the implications are profound. Infinitely many stars, infinitely many planets, infinitely many possible conscious minds. Every possible configuration of matter repeated infinitely. Civilizations isolated by cosmic distances. No cosmic center or privileged location. Meaning found locally rather than cosmically. Here's what we can conclude. Contemplating infinity changes how we understand existence. It humbles us. It challenges our assumptions. It invites us to think deeply about what consciousness and meaning really are. That 15-year-old me, struck by the vertigo of infinity, was onto something important. Not because infinity necessarily exists, we don't know that yet, but because thinking about infinity reveals something true about the universe and about us. The universe is vast beyond intuition. Space might be infinite. Consciousness is rare, local, and meaningful. That's the message infinity conveys. If space truly is infinite, then we live in a cosmos so large that we can't grasp its totality. But that doesn't make our existence meaningless. If anything, it makes it more precious. You're conscious in an infinite universe. Your thoughts are your own, even if infinite copies of similar thoughts exist elsewhere. Your connections with others are real and valuable, even if other beings are separated from you by cosmic distances. An infinite universe is not a reason for despair. It's a reason for wonder. And wonder, the capacity to look at the universe and contemplate its scale, its structure, its fundamental nature, might be the highest achievement consciousness is capable of. If space is infinite, we live in infinity. And that's beautiful. I want to leave you with one final thought, a meditation on what infinity means for how we should live. If space is infinite, we are inhabitants of infinity, not visitors to infinity, not observers of it from outside. We're inside it, embedded in it, part of it. That changes things. It means we're never going to escape the universe and see it from outside. We're always going to be embedded within whatever it is. If it's infinite, we're embedded in infinity forever. Some find that claustrophobic. We're trapped. We can never leave. We can never see the whole picture. I find it liberating. We're not required to escape or to see from outside. We're allowed to live inside infinity and explore it from within. We're allowed to find meaning within the infinite. That's what humans have always done. We're born into a world vastly larger than ourselves. We live in it. We build relationships and create meaning. We explore and understand what we can. An infinite universe just makes this permanent and absolute. You will never see the outside. You will never know the whole. You will always be exploring something infinite. That's not a curse, that's freedom. If the universe is infinite, then every conscious being who has ever lived or will ever live faces the same fundamental situation: existence within infinity. Not knowing the whole, not capable of knowing the whole, forever discovering new aspects of reality. In that sense, all conscious beings, across billions of galaxies, across billions of years, infinitely many beings in infinitely many times and places, share a fundamental experience: the experience of being finite minds in an infinite cosmos. That's a kind of connection, a cosmic fellowship, all consciousness united in wonder. If that's the reality we live in, it's not something to fear, it's something to celebrate. A universe so vast that consciousness can emerge and discover itself. A universe so grand that awareness means something. A cosmos so immense that finite minds like ours can spend lifetimes discovering its wonders without ever reaching the end. That's the gift an infinite universe gives us. Endless frontier, endless mystery, endless reason to wonder, explore, and seek meaning. If space is infinite, we're infinitely lucky to be conscious within it. That's enough. That's everything. That's the answer. That 15-year-old me lying in a field, struck by vertigo at the thought of infinity, couldn't have fully understood what he was thinking about. But he understood something true, that the universe is vast, that space might be infinite, and that contemplating that fact changes how you see everything. Decades later, I still return to that feeling. Not often. I'm usually caught up in daily life. immediate concerns. But occasionally, usually at night, when I look at the stars or think deeply about cosmology, I feel it again. That vertigo, that awe, that sense of being embedded in something infinitely larger than myself. And I've learned to embrace it rather than fear it. An infinite universe is not a threat to meaning. It's the ultimate context for meaning. It's the reason consciousness matters at all. So if space is infinite, and odds are it might be, let's live as if we know it. Let's build locally while thinking cosmically. Let's create meaning while acknowledging our insignificance. Let's connect with others while recognizing they're infinitely precious in an infinite cosmos. That's how you live in an infinite universe, not with despair, but with wonder, not with resignation, but with curiosity, not alone, but connected to every other conscious being who's ever looked up at the stars and felt the same infinite vertigo. We're all in this together, embedded in infinity, thinking our thoughts, creating our meanings, being conscious. And that's everything. And so we reach the end of this exploration, though end feels like the wrong word for a discussion about infinity. There is no end to infinity. There's no conclusion to contemplating something infinite. There's only deeper understanding, more nuanced appreciation, fuller acceptance of the vast and possibly infinite cosmos we inhabit. What if space is infinite? Then we're infinitely fortunate. We're embedded in something eternal and endless. We're conscious observers of the cosmos. We're part of the universe understanding itself. And that makes all the difference. Space might be infinite. Time might be infinite in the future. Consciousness might persist eternally in some form. These are not threats. They're opportunities, they're invitations to live deeply, think widely, wonder endlessly. So go look at the stars tonight. Feel that vertigo. Embrace that awe. You're conscious in an infinite cosmos. That's the ultimate meaning. That's everything.